Thanks everyone who's on the call, conveyed the call. This is going to be a really, really good presentation. I think you're going to like it. It's definitely going to leave you with food for thought at the very least. We talked yesterday in our industry meeting about the high RAP RAS framework that we're working on that Caltrans wants to move forward with. So I think this product that we're going to talk about today will fit right in there. And so without further ado, let's go ahead and start the discussion. And I think Kaylee Laliker is going to do the presentation, and then we should got some backup from Bill Dempsey, and is it Marie or
Marie? Thank you.
Okay, and your last name I don't want to butcher. Krieger. Okay. Are here to back her up with some Q&A. So if you have some questions, go ahead and while they're doing their presentation, go ahead and put them in the Q&A. And when we're done with the presentation, we can take on those questions and get the information that you need. So without further ado, Kaylee, you want to take her away?
Great, thank you. I really appreciate the opportunity to give this presentation today, and thanks everybody for being on the call. I'm going to go ahead and share my screen. All right, so again, my name is Kaylee Laliker. I am a policy and advocacy manager with CertainTeed. And so today, like Tony said, I'm going to be talking about a new technology for processing RAS. And it's in a way that addresses a lot of the historic challenges that people have seen with including RAS and pavement. And it allows for, first and foremost, good quality pavement, but also allows for the increase of recycled content. So before I get into the detail, I just wanted to tell you a little bit about who we are, how we got involved in this. CertainTeed is a manufacturer of building materials, including asphalt shingles. We have a manufacturing footprint throughout North America. We are part of a parent company called Saint-Gobain, which is one of the world's oldest and largest building materials companies. And we're also very committed to sustainability. So, we're looking to be a leader in light and sustainable construction. And one part of that we're very much focused on is improving the circularity of our products and finding ways to get that material back into either our own products or other useful products. So to that end, last year we acquired technology from this company called Asphalt, which had developed a process for producing pre-treated pelletized RAS. And ultimately, we would like to be able to recapture RAS back into our own manufacturing process. So we're working on that through R&D. But we also recognize this is a technology that can be used today to make RAS not just an acceptable addition to the mix, but the pavement mix, but a beneficial one. So we're here working to explain the process, work with producers and agencies, and ultimately would like to see this technology used more broadly. And in particular, California is our top priority for where we're focusing geographically. We have a significant presence here with two roofing manufacturing sites. So we're really happy to be able to present to you all today. And with that, I'll go ahead and get into it. So just first, I'm going to talk about something that may be familiar to those of you who have experience with RAP, and it's just the history of challenges that have been seen with using RAP and pavement. So going back to the 1990s, when there were some initial reports that were exploring the use of RAS in pavement. And there was a lot of focus in those reports on the process and the handling of the material, the economics, but less discussion on how including that material actually affects the pavement mix. So beginning in the early 2000s was a period of expansion. There were a lot of recyclers that started to enter the RAS market and accept shingles. And they were seeing that they were able to offset their costs for processing the shingle waste with tipping fees. So it was, a viable business proposition for them. And then, the contractors using the RAS were adding it to the mix without necessarily accounting for the fact that that aged binder in the RAS was not actually blending well in the mix. And there were also some issues just managing the RAS at the plant. The ground shingles were difficult to consistently feed into the mixture.
Hey, Kaylee, sorry to interrupt. I don't think we can see your slides advancing. It shows like that it's not on the presentation mode on the screen.
Okay, I'm on it. To me, it's showing up the slide that says challenges in RAS usage.
Yeah, we're still on the first one.
It's like before presentation mode.
Yeah.
So I think we're maybe seeing the wrong screen.
Let me try to stop sharing and see if I can redo it. Okay, are you seeing it now?
No, I saw you click the presentation mode, but it kept it on the kind of the slide deck section and not the slideshow.
Okay, does it work if I just do it like this? Is that big enough for everybody to see?
I think so.
Okay, sorry about that. I'm not sure what's going on with that. But so anyway, fast forwarding then to the 2010s, and started to see some failures in pavements that had included RAS, and primarily premature cracking was the concern. So there was more research done by Federal Highway Administration, NCAD, and others, and they looked at PG grading of the asphalt that was extracted from the RAS and found that it was as extreme as 175 plus 41. So obviously that lower end was being significantly impacted by that aged asphalt. So because of this, the Federal Highway Administration, I believe it was in 2014, sent out a memo kind of warning about this to the state DOTs. And so the use of RAS started to decline as a result. And as it declined, there were other issues that arose. There were some concerns at the HMA plants about handling the material with the ground shingles from a standpoint of fiberglass, airborne fiberglass, and then also as usage declined, there were a few kind of high-profile instances where there were large stockpiles of shingles that were left at recyclers and abandoned and had to be cleaned up by local authorities, which again kind of turned the opinion against this use. So the result of this was that usage has fallen out of favor to a large extent. A lot of producers stopped taking in unprocessed shingles. And you can see this in the estimates of the tons of RAS used in hot mix asphalt declining. So in 2014, it was almost 2 million tons in the US. And then by 2021, that was down to 630,000 tons. And then, in comparison, the amount of shingle waste that's generated annually is about 15 million tons. And, the majority of that material, the, asphalt, cement, and the other resources that are part of those shingles are being wasted. So the goal is really figure out how do you recapture that material without having these problems that affect the quality of the pavement. So that's the kind of challenge that the Asphaltica process is addressing. And the key to the process is that it pre-treats the res. So rather than, the traditional way of doing it, which is that you would add the ground shingles and possibly a rejuvenator directly into the hot mix where, that mixing process is occurring in a matter of seconds. This process treats the res over a period of days and within this protected pellet. And that allows the asphalt content in the res to be sufficiently softened beforehand, before it's ever added to the mix, so that it then can blend effectively. And you can kind of see how this difference actually works by looking at the PG grading of the material. So this is a chart that shows the PG grade of the asphalt that's extracted from untreated ground shingles, which is sort of the historic way of doing it, versus asphalt extracted from these pre-treated asphaltica pellets. So the orange bars here, the top and bottom of them are showing the upper and lower PG numbers. And those two blue lines are just for comparison, just showing a PG grade of 64 minus 22. So the first bar on the left is showing untreated res that comes from manufacturer waste. And then the second one showing untreated res from post-consumer waste. And you can see in both cases, the bottom end of that's very affected. It's 0 or plus 41. And then you compare that with the third orange bar that's showing the res from the recovered from the asphaltica pellets. And so you can see the lower end is much better for the asphaltica pellets, and once the res has been pre-treated in this way, it actually contributes a very good binder for pavement. And then kind of similarly, this is now showing the PG grade of the asphalt recovered from mixes including no res versus ones including the asphaltica pellets. And so the first bar here is a mix with 25% wrap and no ras. And then the second has 25% wrap and 3% asphaltica pellets. And then the third has 25% wrap and 5% asphaltica pellets. So you can see that as you're adding the asphaltica pellets, there's improved top end and then very minimal impact to the bottom end. We've also done ideal CT testing to compare different mixes without res to mixes with the asphaltica pellets. So this testing, we looked at 3 mixes. They all had 30% wrap. And then we had one with no res. We had one with 3% asphaltica pellets and then one with 5%. And what we actually found was that as you add more of the res pellets, the CT index actually increased. So you can see that on the chart on the left. It went from a value of 34 with no res and then 77 with 5% res pellets. And then this is just showing, the report from that testing. And, this is very interesting result because it shows that the cracking resistance actually increases with the addition of the asphaltica pellets. So, to kind of recap what we found about the effect of this process on the mix, the PG grading confirms that this is a process that does result in better blending, and the pellets are actually contributing high quality binder to the mix. The shingles contain fiberglass fibers, which contribute to reduced rutting. And then ideal CT testing showed improved resistance to cracking with the addition of the pellets. We also know that hydrated lime, which is the coating around these pellets has been shown to increase asphalt performance. And then the other thing just wanted to point out is that this pre-treatment process doesn't require any heat or solvents. And it doesn't require separating any of the components of the shingles. So the whole shingle can go in there. There's no yield loss. So, in addition to these kind of performance issues that, I've been mentioning, this process addresses some of the operational issues that have been seen with using RAS at the HMA plant. Pelleted RAS can be fed using the same type of equipment as RAP, which allows you to have a better, more consistent feed rate. And I'll see if you can see this video that I'm showing that just shows you what it looks like when, the pellets are being fed. So another thing is because the RAS is already in pelleted form, it reduces concerns about airborne fiberglass from managing all that ground RAS at the plant. And then, another advantage is in storage. In the pelleted form, the RAS can be stored indefinitely in a stockpile, and it doesn't require, reprocessing if it's been stored too long, unlike when you just have a stockpile of ground RAS. If it's stored for more than a few weeks, you may have to reprocess it because it reagglomerates in the stockpiles. So that's another kind of operational flexibility advantage.
Kaylee, is that on the belt? Is that 100% RAS, or is that RAS on top of something else?
I believe it's 100% RAS pellets.
Okay.
Can you confirm that?
It's 100% RAS pellets, and that was when we were initially making pellets. And if you look, there's some oversize in that process in the stuff we're feeding, but and so we had some plus 3/4 minus in this video, but since then we've gotten a control on the sizing of the pellets.
What is the typical top size on it? 3/8 something, or
No, 3/4 minus.
3/4 minus? Okay.
Yeah.
And going back to the previous slide, I think it was the previous slide, you mentioned hydrated lime. Is that the coating?
Yes.
Okay.
Currently.
It seems like you might have some states that use hydrated lime might be okay with that. But that's
Okay. Okay, so then I just, obviously we're here because we want to expand the use of this process into California, but it has already been proven in other locations. There's been over 625,000 tons of hot mix asphalt produced using the Asphaltica pellets. They can be added up to 5% of the total mixture. And just to give you kind of a basic sense of the amount of recycled content that can be recaptured through this process, a typical plant could recycle 35,000 tons of shingles per year, and then that would equate to about 7,000 tons of asphalt cement that's being recaptured and reused, and then displacing virgin material. So this is a table showing where mixes with Asphaltica pellets have been allowed and used so far. The pellets have been introduced at 7 hot mix plants in Washington, Oregon, and then the resulting mixes have been used in paving projects in these jurisdictions, as well as a variety of different private industrial jobs as well. So what we would like to see is, obviously for Caltrans, to develop standard specifications that allow for this use of pre-treated and pelletized RAS. And I think, another thing to mention in addition to, the kind of the benefits I've covered is just the way that this fits in with overall policy objectives that, state and local DOTs have. So it enables the increase in recycled content in road materials, which is, an important thing from a policy perspective, and recaptures the value in of the asphalt cement in these shingles that otherwise would go to waste. But most importantly, it does that while maintaining the same or better pavement performance. So, we are ready and willing to help provide any information or anything else that we can do to help with development of these specifications. And then this is kind of, I won't go through this in detail, but this is sort of summarizing what I've outlined in this process, which is that, there are a number of different challenges that we're seeing in the past that sort of discourage the use of RAS, but we really think that through this kind of innovative processing technology, you can address these challenges and really create a RAS product that is a beneficial addition to the mix. And I believe that's it. So with that, I'm happy to take any questions. As Tony mentioned, we've got Bill and Maury here. Bill is the kind of the technical expert. He's one of the inventors of this process, so he knows a lot about it. And we're ready to take any questions. And I'm going to go ahead and stop sharing just so I can see better.
So Abby, how do you want to access these questions? You click on it, or how do we? There's one question in the queue, it looks like.
Yeah, they'll be in the Q&A, or they can raise their hand if they want to ask it verbally.
There's two in the Q&A. How do we get to those?
You just click on Q&A and then it'll pop
In
up.
there? Okay.
Yeah.
I can see them. So one of the questions is this an on-site pellet system? So one thing I didn't mention is that basically, there's two ways that this could be done. Kind of two models. So one option is for the asphalt shingles to be taken to a recycler where there's, a pelletizing plant. So the shingles would go to a recycler, they'd be ground, pelletized, pre-treated there. The resulting RAS pellets could then be taken from the recycler to the hot mix plant for introduction into the mixture. So that's one option. You also could have, a hot mix plant that has a pelletizing plant on site. And then the, shingles could be delivered directly there, where they would be processed using the same process, and then introduced to the mix. And then I think, one thing to note about that is that because of the additional flexibility in storing of the pelletized RAS, it kind of opens up a little bit more options in terms of, they can be stored at the recycler and then provided to the hot mix plant, if that's the route that, somebody decides to go with it. The other question was mixing time. So I assume this means the time that the pre-treatment occurs in the pellets, which is a period of days. I don't know, Bill, if you want to provide.
I believe that mixing time is probably what at the asphalt plant, and you have no different mixing time. You on the amount of pellets that we've made and used over the last 2 years, we put them through a standard counterflow asphalt plant and also a old batch plant, and Lakeside did not have to adjust the mixing time at all. And the on-site, as far as the on-site, the model that I would think would make the most sense is if the hot mix manufacturer has enough room, he takes in the shingles, or takes them from a sort somewhere that they went down a pick line and grinds them, pelletizes them, and then from that site he can disperse them to all of his asphalt plants.
Bill, how's it typically being done today? Or are you doing more delivering of the final product to the plants, or are people doing, as you're saying, creating the pelletized product on site at their plant?
Currently, the plant is kind of a standalone at Lakeside's facility, and then they disperse it out to 7 different asphalt plants.
Would you know if we got this going and Caltrans gets a spec out there that allows 3 to 5% RAVs, would there be any thought, or maybe you kind of got to cross that road when you get there, would there be any thought to having a product ready to go in California that you could just deliver to the hot plants? Or do you see that as probably more of the contractor doing what they're doing now, taking in shingles, getting them processed, but then taking the extra step to make the pelletized version?
I think either would work. I think what you're talking would be a standalone business, whether it was a recycler like Kaylee was talking about. And then if a contractor got the project, he could buy from the recycler, buy the pellets, and that would probably be better for everybody on the level playing field. But if a contractor wanted an advantage on oil savings, he would do it in-house and vertically integrate the process.
I'll go ahead and let somebody else ask the question.
Okay, we got a few other ones in here. So there's two similar ones. Is this a product for sale, or is there licensing, or both? And then someone else asked, are you selling the technology or equipment? So we are seeking to license the process. So we're not in the business of producing and selling these pellets. What we're looking to do is license them, and like Bill was saying, either to a producer who would like to use it at their site, or a recycler also. So that's what we're looking to do. We wouldn't be selling the pellets themselves or the equipment.
Okay. So if somebody was interested in getting into the pelletized RAS business, they could get licensed to make the product and then sell it to other hot plants, other producers. They want.
Correct. Yeah.
That'd be one way that could be done. Okay.
What is your typical recycled asphalt content percent? So the RAS pellets themselves have about 20% asphalt content. So each 1% RAS pellets that are added to the mix would replace about 0.2% binder, and we would recommend including up to 5% of the total mix by weight. So you could have up to 1% replacement. We also got a question, does the product have an EPD? That's a good question. So we are aware that, especially in California, kind of the growing desire to have an EPD that goes along, or an LCA that goes along with asphalt products. So we're aware that's a need, and that we are working on developing that information for the Asphaltica pellets with industry groups, as well as on our own. So we don't have an EPD yet, but we definitely recognize that that's a need, and we're working on that. What size does the processed shingles need to be? I don't know. Bill, did you want to take that one?
I'll answer that. So the process is to put a 1/2-inch screening medium in your grinder, and that grinds the shingles down to a fairly small size, and then it's sent through a trommel screen with a 3/8 inch square opening. And so the overs, which isn't much, gets put back into the grinder. So what it really is a 3/8, but we're not grinding to a 3/8. It's just tough to try grind a 3/8 shingle or down to a 3/8 size. But even at a 1/2 inch, when you're grinding, you don't get very much that's above a 3/8.
That, you know, when some work has been done in California, they're looking at tear-offs and also manufactured waste. And it was at the time I recall there was some manufactured waste that was very, very difficult to shred because the oil was so fresh in there. You don't really run into that problem so much in making this product of, you know, tear-offs versus manufactured waste.
Now we haven't seen, we have in the past ground manufactured waste 100%. We've ground 100% tear-offs and also a 50-50 blend. And if you got a polymerized oil in your manufactured waste, if it's high polymer, you would probably want to go with a 50-50 blend. But I believe, I don't know how many shingle suppliers, that would be a question for Mari or someone from Certainteed, that puts polymer in their shingle process.
Yeah, that's really dependent on the regionality. It's more common, I would say, up where you are versus down in California.
So it'd be interesting to see if you could just based on that binder replacement alone. We know binder is one of the biggest contributors to the greenhouse gas and the GWP number. It would be interesting to see if you had a mix that, you know, with 0 RAS and a mix with 3% and a mix with 5% in the replacement of that binder, that virgin binder, what that kind of impact that would have on your EPD/GWP value. What are you really gaining? Or I would think you would be gaining quite a bit in reduction of GWP by replacing that much binders. So if you guys do, you know, I know you're going to do some more work in this area, obviously, that would be something that I think we would be interested in seeing how that impacts the EPDs.
Yeah,
Yeah.
I think that's a really good point. I'm assuming you're talking about utilizing the eco-label tool to create the EPDs, and the data that's in there right now for RAS is lower quality than I think the industry would prefer to have. And so there's several different efforts going on within multiple industry groups to improve that number of just the ground RAS.
Yeah.
And then our plan is to take that industry average data, utilize that for the EPD for the asphaltic pellet to make sure that it's apples to apples across the industry to be able to use that data going forward. Does that make sense to you?
Yeah.
Okay.
Sounds good.
Okay, and then the only other question I see in there is who do we contact to discuss licensing and get additional information? You know, it would be Mari, myself. I just put in my I believe I put in my email address that I responded in the Q&A. Okay, I see it's under answered now.
And we can
Just
get
so
it
you
out.
have it. Okay,
We can get it
yeah.
out, but I'll share it afterwards, the information with
Okay.
it as well, just in case.
Okay.
Great.
And I think that was it. Are there any other questions?
How since you're doing this in Oregon and Washington, so I'm going to make an assumption that the binder or the RAS binder in terms of PG grade and stiffness is pretty consistent, that you can start with the mix design with the product in your mix design, and then as you produce, if you you know, you're going down the road and for some reason somebody says, hey, we need to check the binder properties on this mix, that it's consistent enough where you're gonna still be where you need to be in terms of what your mix designed.
I think that depends, Tony, on what, like we were talking, California didn't want the higher end to go up. So it depends on the agency's specifications and how tight they are on the band of PG grading. So, but if you have a 6422 spec and you make it a 70 minus 28, to me, they're getting a better product. This, what we have seen is this doesn't hurt the PG grading. It doesn't collapse the band at all. It broadens it. And I've got to answer the question on what is your typical recycled asphalt content? Because I know the guy that sent that, and he'd be mad if I didn't answer it. What the average recycled content in Washington and the Portland, Oregon area is about 4.5%. And I think that is what you're asking, Bob.
I'm not sure if he's able to get off mute or not.
Yeah, he asked another question too, Kaylee, if you want to, or Maury.
Yeah, so that question is, do you expect the addition of these pellets to neutralize the carbon impact of the virgin asphalt? So again, that's kind of something that would need to be addressed through going through the LCA and EPD process. I mean, it certainly displaces virgin asphalt, but there's other things that need to be, included in that LCA and EPD to actually quantify like the net impact. So that's definitely something that we want to go through, because I know this is a kind of a critical question, and especially in California where they're, far ahead, I would say, of other states in that area.
Yeah, I agree. We anticipate that it will have a positive impact, right? If it has a negative impact, that's a problem. So the anticipation is that it is, but again, we don't have that data, so I don't want to say 100% conclusively that it will.
Yeah, I got mentioned earlier. I think that we might end up not having a top end criteria on the binder properties, which will, again, to Bill's point, that's a good thing. It's not going to hurt anything, and the bottom goes down into the higher the number, the better.
I think I'm off mute now, folks. Did that work?
Yes, it did.
Okay. Yeah, good answer, Bill. And yeah, on the EPD front, it's definitely time consuming and eats up a lot of resources. But to me, just looking at it, if the RAS is considered a waste product, that's going to be a really big deal long term, because diverting that material from the landfill should be a big carbon neutralizing impact to the mix as a whole. So seems like that could be a good deal.
Yeah, and you're eliminating all the, the extraction of the binder, the transportation of the binder. That goes away. Well, not completely, because you are moving shingles around. But big difference, I think, between the two in terms of contributions to the carbon contributions.
Yeah, because the carbon impact of the asphalt, the virgin asphalt that's going in, that's considered a new material. So yes, that has a big negative impact, and this would be a positive, as long as it's actually considered a waste product and you're diverting from the landfill. If that's the classification you get, it should be a big carbon neutralizing tool.
Yeah, definitely.
Well, you got to pay some people a whole bunch of money to get that all in a form of EPD.
Well, we'll cover that, but I think it's just recognizing that it's not a quick process to develop the EPD and ensure that the data integrity is there. And then also, you know, it will be a multi-step process, like I mentioned, simply because the data for RAS that's in the Eco Emerald tool, I get those words backwards sometimes, so I apologize if I named the tool wrong, is not great quality right now. And so it would be making sure that when the updated RAS numbers are released, and that effort is actually kicked off and completed in a year and a half, that then the data is updated again accordingly. But you're right. I mean, the anticipation is that it's a very positive impact because you are utilizing reclaimed materials in more than one way than just the shingles. Some of the other components within the pellet are also reclaimed, which is a great incentive. And it's also a very low energy intensive process compared to others, right? There's no heat, there's no drying. And so it's not a energy intensive process.
Marty, do you want to answer the one from Anonymous? What is the additional cost per ton of ground shingles?
Oh,
So-
absolutely. So that's something that we'd be happy to walk through with you individually. What we have found is that it's a cost savings mechanism for the HMA producer simply because of the binder replacement. So there is the upfront equipment cost if you wanted to bring the pelletizing equipment on site. The licensing fee is low. I will just say it that way. CertainTeed is not out to make this a revenue business. We're out to make this a business to really move all of the products forward. And you know, to be climate positive. You know, we really our company is a company that has very strong ESG goals. We work through the science-based target initiatives, and so we really try to put our money where our mouth is, and this is not someplace where we're trying to make a money grab. It's really to better the society and reclaim the products that are still very usable to go into products that can be used, ensuring that it's at a similar, if not higher value product. So happy, feel free to reach out. I'll put my email address in the chat as well, so you have that. And we're happy to go through that analysis with you. It really is helpful to do it individually because we can take what your costs are and show the cost of the equipment and the cost of the raw materials and really show that cost savings to you on a per ton basis.
That's great.
So Brent asked, will you share your presentation? Yes, we can do that after this. And then we got a question, has Oregon developed and implemented an HMA specification? So yeah, Oregon does allow for the use of RAS in its specification. You know, obviously it's not specific to pre-treated or pelletized RAS, but they do allow it, and we have done projects under the Oregon DOT specifications, as well as some other jurisdictions in Oregon, like the city of Portland. And Bill, I don't know if there's anything else you want to say about the specification in Oregon.
ODOT and WashDOT, Washington DOT, they both allow just grind the shingles and dump it in, but as Kaylee showed in the presentation, that has fallen out of favor, and the contractors are not using very much, if any, shingles RAS. And the company I used to work for was really going great guns on it until realizing the impact that RAS, just untreated RAS, has on the pavement itself. And it was more of an industry decision, not a universal industry, but just the whole industry started to kind of just move away from it, because it really, all you're getting when you dump RAS into asphalt, because of the high melting point of the oil in the shingles is little black filler in your pavements. Some of it might melt, but it's been my experience, it is not effective asphalt, and it actually leads, even in a temperate climate like Washington on the west side, it leads to premature cracking and sometimes raveling.
Okay, how many pelletizing plants are operating across the country? So, right now, there's just, this is just being used in Washington and Oregon, and I believe it's one pelletizing plant, but then it's the pellets are going out to, I think it's 7 different, hot mix plants. Is that correct, Bill?
Yes, it's just one, and it's been in use for 2 years, and there's been close to 800,000 tons of hot mix asphalt laid with this process.
And then we got a question, another one, maybe you can answer, Bill. How does the melting temperature vary between pellets and traditional ras?
Are you talking about are you talking about time, or are you talking about what we see and what we experience? Because what this is doing is it's marinating the shingles and or marinating the ras and softening the oil, so it actually melts. If you go back to the slideshow, it is a paving grade oil that we end up with in the pelletizing process, and so it melts at the standard temperature you're making hot mix. And it actually, the company that's doing it has been putting it into some warm mix too. And that's another really good point, is that this process takes the shingles and makes it a paving grade, so you don't have to overheat your aggregate when you're mixing hot mix to get any kind of mobility of the oil in the hot mix asphalt.
And that's a result of rejuvenating it?
Rejuvenating, yes.
Okay.
All right, I think that was everything in the Q&A. Any last questions anybody had?
I'd like to say the one that someone thanked us for our presentation. John Gardner. I don't know John, but I like him already.
Well, we really appreciate the opportunity to present, and I think these were all like really great questions. So and if anyone thinks of anything else after the fact, we're here and willing to answer other questions or provide any other information that we can.
Okay, we'll be sharing share your email address. I know you're going to put them in a chat. You put them in a chat, but we'll share them afterwards as well, for folks to connect and communicate with you the ways forward. And you know, in California, I want to say thank you first of all for this great presentation. This is really something I really am excited about your product. I think I really personally like the idea of pre-rejuvenating the product before it goes to your plant. That's been the big challenge, we know. You know, I did go to that first, I think they called it the first RAS conference in Denver many years ago, and heard some pretty bad stuff, but you covered it. It was basically Wild Wild West on specs, and we've all learned our lessons, and no, we can't go that route. You know, we got to treat it like everything else and do it right. And I think RAS definitely has a future. Now that we are focused on doing it right. And I think this product's going to help us out, I think, in my opinion, going forward. Just remember anything you can do to help us in California along the lines of how do we make this greener for us, reduce our carbon. That's a big goal of California and Caltrans. And of course, solid waste diversion is another big item. And then it's interesting that, you know, the fibers in the RAS, because Caltrans is kind of indicated they have some interest in fiber. And so it's interesting that, you know, hey, this is another way to introduce fiber into our mix to an extent that you can actually see some performance differentials when you test it as a result of that fiber being in there.
Yeah.
Revenue. So I think those
And
are all.
we also, on the waste diversion piece of it, we have also met with Cal Recycle, and they were very interested as well. So
I'd like to end with this comment: is up to 15 million tons of shingles are thrown away every year into landfills, and there's that for the hot mix industry, that's 3 million tons of asphalt. And everybody knows in the hot mix industry what asphalt costs, and it makes my calculator go to the number plus E sign. So it's a lot of money being thrown away.
yep.
So
Another question for you, Tony, in the chat.
oh, you know, okay.
It said, what is the status of RAS specifications in California, and what do you see as path forward?
Okay, so we did again, a real quick history. We did have a high RAP and RAS pilot project specifications. They were separate, but the test sections, each one of those specs did include RAS. So there was a combination of RAS and RAS, but obviously the RAS spec, pilot project spec, was heavy on RAS. Excuse me, RAP test sections, and the RAS pilot project was heavy on RAS test sections. So we did that. We did learn some things. UCPRC did some testing, so we got some information there, and it looked good from UCPRC's perspective. Since then, we have been asked at the PMPC, which is our Pavement Materials and Partnering Committee, that's joint committee between Caltrans and industry. We were asked within that group to look at formulating a RAP RAS, high RAP RAS in SSP, which is a spec that's not a standard, but it's an initial spec that can be put into jobs. And so we've been working on that, and we've been looking at the Washington DOT spec and looking at a few changes there, like eliminating the top end on the binder stiffness, and where we sample the material to find out that the material, that the binder properties meet the specified binder grade. It's a little different. We're looking at that a little more different than what the way they're doing it in Washington. But you know, a few changes which we think are at this point in time, I think they're improvements. So we're actually going to check. As of yesterday, we had a meeting. We talked about this, and we're going to check the temperature of Caltrans again and make sure that they're still going down this path. Hopefully they are, because I think we got a good spec in front of us that we can work with to get that NSSP written. So if they give us a thumbs up, process, not sure. Process can take time, but we need to go back into the scoping document for a full-fledged work product group. That will take some time. That'll add some time. But the important thing is we're moving forward. We've got a goal, and we want to use RAP and RAS, and the RAP part is up to 40%. The RAS could be 3 to 5. It depends, but at least it'll be at least 3%. So it sounds like we're still moving on that. We're just trying to check Caltrans temperature to make sure that we're still on the same page. And I have no reason to believe they're not, but that's where we are. Hope that answers the question. And if anybody wants to talk more about that, you know, they can contact me. I'll be happy to discuss where we are.
Right.
Okay. We good? Well, thanks again. Thank you again. Very good presentation. Very interesting. And I think it has a future. So.
Great. Thank you for having us. Thanks everybody for joining and for all the good questions.
Okay.
Yeah, really appreciate it. Thank you, Tony, and everyone.
Thank you.
Thank you.
Bye.